reporting and analysis. I'm also an Oracle ACE director. There are 7 of us in the world, ACE directors for the Hyperion EPM BI space. I'm one of the 7. So I've been doing what's now called Oracle Business Analytics, used to be called Oracle Business Intelligence and EPM. Before that was Hyperion, before that was Essbase. I've been doing that for about 20 years now. I know a lot of you will have questions, but we're kind of compressed on time. We only have 40 minutes. So if you have questions, please email me at my very personal, confidential email, info@nrl.com, and I will get right back to you. That's actually my main company email, but they will route it on to me. I also have a blog, looksmarter.blogspot.com. Where I will definitely be blogging about today and about the entire Oracle trip going around South America. And if you want to follow the musings of a delusional madman, that's Twitter. That's Roske, E-R-O-S-K-E. I like talking with translation because people laugh at the jokes 4 seconds after I tell them. It's 2 waves. That's the second wave. Welcome. My company is NRL. I actually founded it back in 1997. We're the longest standing company in the world devoted to Oracle EPM and BI. We are headquartered out of the United States, but go everywhere. We have projects going throughout North and South America right now. We're doing our first project over in Dubai. I was in Riyadh about 2 months ago. And I'm very, very happy to be back down here in South America. That was the extent of the commercial, because we are pressed for time. I will tell you, if you want to learn more about Hyperion, Essbase, Hyperion SmartView, Oracle Business Intelligence, please go out to NRL.com or Amazon or your favorite bookseller, and they're all the best-selling books. So just go out and search for Look Smarter Than You Are, which is what all my books are published under, and you'll find at least 10 books that are out there. So I was going around preparing a presentation on big data, and what I discovered is every person I talked to had a completely different idea as to what big data actually meant. I talked to about 20 people. It was a very small focus group. I got at least 27 different answers on this is big data. So I said, I'm obviously asking very stupid people. I will go out to the internet, somehow thinking that would get me smarter people. And started asking out there, what do people feel big data actually is? And I got even crazier answers. So I said, well, let's take a step back for a second. Let's try and figure out what people are doing with big data, and maybe that will help us figure out what big data actually is. And what I found out is that there are a whole lot of questions that we need to answer that have nothing to do with big data. We've been able to get by. Our companies have been profitable. We've kept the lights running. All of us get to go to conferences. We get paychecks. We've done all of this without big data. So what are the questions we have been answering that we can still answer without the world of big data? So I've made a very simple company up here. I'm up there at the top as CEO. And we have some divisions. We have a marketing division. We have a division that produces products. We have a sales division. The CFO is the finance and accounting division. Then we have the CIO in charge of technology. Well, the marketing person says, it's summertime, at least up north. I want to do a mid-year promotion. I think it would be really great if we went out and sold some new products. So the marketing person can look in their database and say, do we have the capacity, do we have the space to do a mid-year promotion? Well, yes, our people have plenty of time on their hands. We don't normally market things during the summer. We can get all of that out of our traditional marketing database. But just because we can market something doesn't mean we can sell it. We need to make sure that if we promoted something, if we ran commercials or ran newspaper ads, that our sales department would actually be selling it. So our salesperson looks and says, well, in prior years when we've done promotions, how much have sales increased? Did they go up 5%? Did they go up 10%? Well, what we found is that under prior years, when we did mid-year promotions, sales went up 10%. Well, just because we can market it, just because we can sell it, doesn't mean we can actually produce it. We need to go to our manufacturing director and say, could you please look in your database and say, do you have the capacity? and they look and say, yes, based on what we expected already to sell, we have 20% capacity on our machines. You're going to increase sales 10%. That'll still leave us with 10% open capacity on our machines. We can definitely handle the production. Well, now we need to go to our supply chain database and say, if we produced it, sold it and produced it, could we actually ship it? Is there space on the airplanes, on the trains, on the trucks? And the logistics person looks in the supply chain database and says, yes, we have plenty of capacity on the airplanes. The trains don't have much capacity, but our trucks definitely have space to ship this out. Well, just because we want to sell it, and we want to produce it, and we want to ship it, doesn't mean we can afford it. Do we actually have the money to do it? So the controller looks in the general ledger and says, yes, we have a few $1,000,000 of money and didn't know what else to do with it. This is a great idea. Let's definitely fund this initiative. So now we actually do it. We market it, we sell it, we produce it, we ship it. There are some problems that come in. We noticed that the shipments weren't going out on time. We noticed the machines that produced the product kept crashing. We noticed that our customers liked the product, but they wanted something different instead. We could have promoted something else. So we didn't quite get the profit we expected. So the financial analyst goes back after the promotion and says, how much did it actually increase profit? Well, we thought it was going to increase profit 10%. Although sales went up 10%, we only increased profit by 2.5%. So at this point, there's only one thing left to do. As the CEO, I have to, well, two things. I have to take credit for everyone else's work. And two, I have to say, did this actually make my stock price go up? Did I increase shareholder value? Well, I can answer this by going out and looking at the database that shows me what my stock price is. Yes, the stock price increased. The amount of capital, the amount of assets increased. Every single one of those questions up there can be answered with a traditional database. You can either do that with a relational database, or you can do it with a cube, something you spin around, put stuff in the rows, stuff in the columns. I don't need big data for any of those. So what do we need big data for? What questions does big data answer? Well, going back through all of those, the marketing person has to ask, what are people saying about our products? What are they saying on social media? What are they saying on Twitter or LinkedIn or Facebook or if you're one of the people that work for Google, Google+. And what the person's finding out is they like most of our products, but they think maybe we sell cell phones. They think our format is too small. We need a bigger type of cell phone out there. So people are negative that we are not advancing fast enough. So the salesperson says, maybe we don't have the right mix of products. Maybe it would be better if we launched a slightly bigger phone, something more like that. Well, once we got the right product mix, if we had produced that, the manufacturing director needs to find out, why did those machines keep crashing? Why, when we were trying to produce the product, did we run into machine downtime? And what they find out is they have lots of logs. They have lots of mechanics saying things like, well, I fixed this machine because it ran out of oil. I fixed this machine because the gear broke off. I had to fix this machine because the power kept going out. And what they find out is the machines during the summer normally are down for maintenance. We normally take them down because that's our slow time. We didn't have a slow time this year because instead we decided to do an extra promotion. But we wouldn't know that right away. There's no database that says you shouldn't have done this promotion because it makes your machines crash. The logistics person is trying to find out, why did all the shipments get delayed? Why did they leave on time but not arrive on time? And they might find out, well, normally the trucks have less traffic on the roads during the summer. Maybe the gasoline prices cost a whole lot less during other times of the year. They were really high at this time of the year. They don't know that. There's no database that says this is why things were delayed. The controller says, I suspect someone is stealing money out there in the company. I don't know who it is. Big data can actually tell you, mine through all of your information and say this cost center or this profit center seems to be doing something fraudulent. For some reason, money is being spent too much in this area. And over in the CIO's area, maybe he's trying to figure out why the computers crash all the time. Well, we can't just go out and do a survey. We have to look at the information when we fix them and say what trends are occurring. Maybe it occurs a lot that We have too old of machines. Maybe we tried to all upgrade to Windows 8.1 and it crashed all of our computers. And then the CEO, that's my job, we have a very, very important question to answer. What is social media saying about me so that I can find out if I'm going to be terminated? Now, this is not a question I can ask a database. I can't say, is job security greater than 100% or less than 100%? I have to see what people are saying on Facebook or on CNN Money or Motley Fool or LinkedIn, what people are commenting about my job. So all of these types of questions require getting out of those traditional databases. So they did a study a couple years ago where they went out to all the people in charge of data across the world, and they said, we are going to survey you, and you're going to tell us what big data actually means. Well, 49% of people said that it's all data related to the web. It's both external, what people are saying out there in the internet about us, and it's internal, what people are going through our website, what route they're taking, what comments they're submitting on the web. 16% of people said, to summarize this point, they said it's the mass amounts of internal information that is stored and managed by an enterprise. In other words, big data is data that is really big, is what 16% of people said. 7% of people said it's our internal website, and it's what people are doing through our website. 21% of people admitted they had no idea at all what big data actually means, and 7% of people went off in their completely own direction and made up answers nobody else came up with. So half of the people say, okay, it's all the external information and all the internal information. 16% of people said it's just big amounts of data. So clearly we have no agreed upon answer at the moment. So now we're going to go out and we're going to say, okay, in one word, just give us one word as to what big data actually means to you. And we'll see what word appears the most often. So they took all the answers from those data managers and put it into a nice word cloud. And now we have the obvious answer that big data means Hadoop. Okay, well, first of all, Hadoop is not a real word. Hadoop is a technology. It's something we use to store non-structured data. So let's ignore that one. Clearly, those people just meant, well, that's the product I'd heard of that helps me somehow with big data. What other words appear a lot? My personal favorite, according to a lot of people, big data in one word is big. I'm surprised data didn't appear a lot up here. Apache appears a lot, which is a tribe of Native Americans living out of the United States. Oh, it's also a technology. We see experience appear a lot. I don't know what that has to do with anything. Science shows up. Cancer shows up. This one I find really interesting because I saw that and I thought, oh, big data, I guess that's a cancer upon technology or... Well, what they actually mean, the reason you see science and mining and cancer and algorithms appear a lot is because people are using big data to save lives. The second largest cancer research organization in the entire United States is called MD Anderson Cancer Center. Their motto is making cancer history. What they're using big data for is to look at all the people worldwide and try and find out what conditions are leading them to have cancer, what conditions are causing people not to have cancer. They don't know specifically, oh, let's look and see if people are drinking lead smoothies. What they're saying is, let's go out and see where people live. What is their economic level? What access do they have to clean water? How close are they living to this feature, or this feature, or this feature? Is there a history of cancer? Is it something coming up that's new? They're analyzing data by literally thousands of different potential bits of information for each person. They don't know what patterns are out there. They're just capturing it all and saying, let's let big data find the patterns. Let's let big data find the trends that are out there. So if I had to describe big data, I'm going to define it into two different halves. One half is structured data. Structured data is what we're used to. It's records and it's fields. This is a traditional relational database. Structured data also could be a cube, something we're spinning around, stuff in the rows, stuff in the columns. Structured data looks very pretty. If we were doing a wedding, we would do it under a nice little structured data tent. It's very organized. There's one problem with it. It only works on level ground. We're not going to take and put up this nice little wedding tent off in the ocean somewhere. We're not going to take it to the top of a mountain. It has to be essentially in order before I start analyzing it. It's already been pre-sorted, ready to present in a structured data format. Well, now we're getting into the world of unstructured data. You're looking at things like social media, images, video, audio. You're looking at survey information. What are people typing in about your company? You're looking at log information, lots and lots of click paths through the internet. That gets into the category of unstructured data. And I think of this as one of those kind of mountain tents. I can fold it up. I can take it anywhere in the world. At the end of the day, it's not very pretty. I wouldn't want to live for a long time in that type of tent. But the good news, it can handle anything. Whereas structured data works nicely like on flat land. You can put up a tent inside if you wanted to. So they went out to that same group of people and they said, okay, let's ask the question slightly differently. Let's ask where big data comes from. And we'll ask each one of you to give us, we'll say, does big data mean this to you? Does it mean this to you? Does it mean this to you? What they discovered is that 88% of companies said big data comes from transactions. Basically, this could be a debit, could be a credit, could be putting an asset record in, could be a record inside of a relational database. 73% of companies said it also includes log data, such as information coming off of the machines, such as traffic through the internet, basically what people are doing on our website. 57% of companies said it's analyzing email. It's information we have where people have sent us emails or we've sent emails around, such as that IT department I was mentioning. We could look at all of our emails and say, what are people saying about our laptops crashing? Why are people saying that they're going down all the time? What do people instead want out of it? What are our people internally saying about our products? Well, all those left side, those are internal data sources. We have ready access to all of those. On the right side, now we're talking external data. 43% of companies say it comes from social media. It's going out and seeing what people are saying on TripAdvisor or LinkedIn or Facebook or Twitter. 38% of companies say it'd be really great if we could do audio to text. If we could go out and say, what are people saying about us out loud or posting on the internet, and we could somehow turn that into text. What are people saying when they call our customer service lines? They dial into the phone, they yell at us a whole lot. Well, what are they saying when they yell? How can we take that information and start doing analysis on it? And then 34% of companies say it has something to do with photos and video. What pictures are people taking? For instance, say we're running a restaurant. And we think we have the cleanest restaurant in the entire world, but most people are taking a picture of the floor of our kitchen to show that there's mold on it and little cockroaches crawling across the floor. Well, if that's the #1 picture out there, that's what people view my company as. I could have a really very clean restaurant, but if only pictures out there are bugs crawling around, I'm not going to get a lot of traffic coming in. So how can we analyze those photos? How can we figure out what people are saying about us, what people are taking pictures about us, what videos people are posting about us? I saw a study recently up in the United States. We have this major organization called the Center for Disease Control, and they try and analyze disease outbreaks. Like right now, I think they're focused on Ebola at the moment, but they get into minor diseases as well, things like food poisoning. And they like to find out where people are getting sick. Are they getting sick at this particular restaurant? Are they getting sick at this hotel, at this convention center, which hopefully isn't this convention center. This is a very healthy, very clean, you're not going to get food poisoning here convention center. Well, what they found out was they could identify food poisoning issues after they were already corrected. Because it would take days, if not weeks, till people got sick enough to go to their doctors and say, yes, I've been vomiting for the last 3 days. Could you please give me something? Well, also, most people that get food poisoning don't go to the doctor. You just deal with it on your own. You get really sick, don't go to work for a day or two, and then you go in a couple of days later and complain to your friends about this restaurant where you ate. Well, what they discovered, though, is that nowadays, when people get really sick at a restaurant, they may never go to a doctor, they may never go out and tell the Center for Disease Control, but they'll tell the entire internet. They'll go out on Facebook and they will complain, I just had the worst meal ever at this restaurant. They will go out on Yelp and they will or TripAdvisor, leave a very long review that says, I ate at this restaurant, you should never go back, I ordered the pasta and I've been sick for 2 days. So what the Center for Disease Control found out is the best information on food poisoning is not what the doctors were supplying them. It was by going out and looking for keywords on social media. They could actually go out and location by location search for unpleasant words, like vomiting or sick or we'll never go back there again, my child feels horrible. They will look for these key terms, and they can actually show on a map, this restaurant has a problem, this restaurant has a problem, this restaurant has a problem, and they will know that information within 6 hours. So that's us. It's basically us as people giving information to the world. We're sharing. We're providing data that somebody just needs to analyze. So if you look at that structured versus unstructured, the only two types of structured data we have are transactions and log data. There is no specific format for an email. Nobody tells anybody on social media, other than Twitter being 140 characters, nobody says on social media, your Facebook status has to be in this format. It has to have both nouns and verbs. It has to be, a couple of sentences. It has to follow this pattern. Nobody knows any idea of what format any of those unstructured bits of data will come in as. Now, there's an interesting question that comes up, which is who is analyzing big data? I talked about the Center for Disease Control, Walmart, which is the largest company on earth. They're doing a ton of social media analysis. What are people saying about our products? What are people saying about our stores? What types of trends are people starting to look at? So people start thinking it's only really, really big companies that are doing analysis of big data. Interestingly, it's also really tiny companies that are analyzing big data. If you only own one restaurant, you are out there reading every Facebook post, every Yelp post, every TripAdvisor post. Every time someone tweets the name of your restaurant, you're reading it and you're doing something about it. So if you're a small company, you don't have an automated method for analyzing big data, but you are analyzing big data. You're getting outside of your company. Interestingly, between the small companies and the really big companies, that's the space that isn't doing big data analysis right now. And they're missing out on a huge opportunity. The major difference is those big companies are automating their analysis. Those big organizations are taking the data that's available off the internet, taking the log file data, taking the transactions in the email, and they're automated and analyzing it. Those tiny companies are just people. It's individuals going out and saying, what are people saying about them? So surely there must be a product. There must be something between the small companies and the big companies. There must be at least one software product out there that does some big data analysis. Yes, there are about 100, and then we got bored adding them all in. Whether you're trying to say, I want big data as a service, I want a technology, that's where Hadoop appears a few different times. I want more of a server technology. I want to do analytics. I want to do visualization. All of these are components of the big data landscape. Now, right now, there are only 3 companies that appear really more than once on here. IBM appears a couple of times. Oracle appears a couple of times. Microsoft appears a couple of times. And then the Hadoop technology appears a few times, which is good because that was the #1 name from earlier. But you can tell it's a very fragmented landscape right now. There's no one company that's dominating. That's because big data, even though we're all talking about it, is very much in its infancy. We aren't in a situation yet where the industry has started consolidating down to a few specific products. So right now it's very, very fragmented. If you look at big data, one of the problems with it, first of all, big data is big. It's a horrible way to define it, but it's much bigger than it used to be with traditional relational data, cube data. If we look back at ERP systems, that would be things like general ledger, asset systems. It's very specific. I purchase an individual item. I put an entry into my general ledger system. I divest myself of an asset. I go out and buy something. Those are very specific formats, and there's not a lot of data. Then we got slightly bigger. We got into what are called CRM, Customer Relationship Management Systems. Now we have to interact with a customer. And you might interact with the customer by calling them. You could send them an email. You could tweet at them, I guess. You could, take a selfie and send that to your customer. There's no limit. There are probably some limits to appropriate contact with your clients, but there are no limits to the ways you might interact. We have to track all of that in a CRM system. Well, when we get even bigger, now we have the web. So we have people coming in through our website. It could be hundreds of millions of different people. We might be offering each person a different price. The price might change based on the time of day. Now we're getting from gigabytes of information to terabytes of information. And as we go from each level up, it gets more and more complicated, and the way the data comes in is much more varied than it used to be. Then we get up into the big data space. Now we're getting up into petabytes, so thousands of times the size of terabytes. We're getting into things like speech to text. We're getting into video, audio, images. We're doing analysis of maps, GPS, spatial information. We're analyzing what people are saying on a social media, social interaction with our company. We don't just want to know what page they clicked on anymore. We want to know what route they took through our web page. Did they click on our home page? Then they clicked on our product page. Then they clicked on a detailed product page. Then they went to buy, but then somehow got to the help page and then left our website. Why did they do that? We were so close to making a sale. Why did they quit us? Why did they move on? Well, now we're looking at even more varied data, and we're getting up into petabytes. So in the world of big data, for those of you that are new, you will start to hear about the V's of big data. I will tell you what these V's are. There are 3 V's that everybody agrees to, and then there is 1 V of big data that everyone argues about. So I will tell you from me what the 3 are that everyone agrees to, and then I will tell you my own personal V. So the first V of big data is volume. And what this means is just the size, the scale of the data. When you get out into analyzing what the entire internet has to say about your company, that's a whole lot more information than what you're capturing in your data warehouse. Second, the velocity of data. As I just said, if people are saying bad things about your company online, you can't wait until next month to realize that. This is much faster than, say, doing financial analysis. Most finance analysis, accounting analysis, that waits till the month ends, and then we get 5, 10, 15 days into the next month to realize, oh, we lost money, darn. Well, nowadays, somebody says something bad about my company, bad about my restaurant. I can't wait 45 days to find out that there were cockroaches in my kitchen and that I had food poisoning issues. It's too late. Nobody will ever go to that restaurant again. So it has to get to real time. Third is variety. It's no longer records, fields, or cubes. I've got text, audio, speech, images, video, emails, you name it, data is coming at me from all different directions. The fourth V, in my opinion, is what's called veracity. And veracity means you can no longer trust your data. If you talk about data internally, you might hear garbage in and garbage out. There might be bad customer numbers, or maybe an invoice number is incorrect. But at the end of the day, you can look at that number and say, is it right, is it wrong, do I need to change it? Well, on the internet, everybody can just make things up. I was doing this presentation one time. True story, I was doing this presentation in the Middle East, and I had a Twitter feed up and live, and I encouraged everyone to tweet comments about my presentation. And I said, I'm going to analyze big data, and I'm going to do it in real time. I gave everybody my Twitter handle. During my presentation, a guy named Bjorn Roske tweeted, "Edward has the ugliest purple hair I have ever seen." Okay, for what it's worth, my hair is not purple. I do not have ugly purple hair. I do not have beautiful purple hair. I do not have purple hair. Because on the internet, nobody says you have to tell the truth, that your comments have to be accurate. This is not how we have it internally. Internally, you're not allowed to make things up within inside of your company. So now, how do I sift out that good data from that bad data? How do I figure out what the outliers are and start ignoring it? So if you look at, as we go from small batch data, 15, 20 years ago, to more periodic, to near real-time, to real-time data, the volume increases, the velocity increases, the variety increases, and the veracity, the fact that I can no longer trust the data, also increases. So I like pictures, and I came up with this idea talking to my children. They were playing with their Lego bricks. They were trying to make like little structures and things. And they had a great big pile of everything in Legos. And I looked at it and I said, that's big data. That's that junk we're getting from all over the internet. And there's something good there, but I don't know what it is. I don't know if the number one color is red, the most common color. Is it white? Is it green? Is it blue? I don't know. First thing I have to do to make sense of that big amount of data is I have to sort it. So I'm going to take it and sort it by color. And maybe I could sort it by size. I could sort it by which ones are longer, which ones are shorter, which ones are taller. I'm going to sort it in this case by color. So as you can see, I have 8 colors: black, yellow, kind of light green, white, blue, red, orange, dark green. I think that's 8 colors. At this point, if I had to guess, I'd say probably red is the biggest color. But I need to arrange it. Just because it's sorted doesn't mean I've actually put it into a traditional database somewhere where I can normally analyze it. So sorting it is taking all the amounts of big data and saying, okay, let's group it into this category, into this pattern. We're going to start doing something. But now we need to take it and put it into our traditional relational databases, put it into our traditional cubes. I have to arrange it. So now I start stacking it up, so it's not just a pile anymore. I'm putting the bricks all on top of each other. Now it's quite obvious the number one color by far is yellow, right? That's the color over there. We can tell there's more of this brick than anything else. But now that it's sorted, now that it's in a relational database and nicely arranged, now I need to present it. I need to actually go out and show the world this is what the data actually looks like. And when I do this, I find out there are actually the same amount of red bricks as yellow bricks. Once I started making a nice pile and clicking everything together. You couldn't tell it before, but yellow and blue were the exact same size, and that all four of those other colors were completely equal. So light green, orange, dark green, and black, they were the exact same. And here's something really interesting. There was a little gray brick that was hidden in that pile of information up above. Now this is where we get into the veracity. This is an outlier. There's only one gray brick that's out there. Now this could be completely bad information, that's something that we say, we looked at this and this brick, it's not like any of the other bricks, we don't care about it, it thinks Edward has purple hair, that's obviously incorrect. Or it could be somebody saying, I really like Edward's hat, it would be even better if he was wearing a purple hat. Okay, never thought about wearing a purple hat, but that at least is a new idea. It's not something that's incorrect, it's just something no one has suggested before. So this gets us into the final question. So we've got about 10 minutes left. So big data, part of it is collecting. We've taken all that information, we've started bringing it in. Sorting it means we're looking for patterns. We're deciding what goes into each individual space. Maybe we're going to analyze positive comments about our company. We're going to analyze our product mix. We're going to analyze which locations people like, which locations they don't. Arranging it is taking that sorted data and putting it into something more like a relational database or putting it into a cube. Presenting it, though, is the hardest part. How do we take huge amounts of data, summarize them to the point where we can actually go back and deliver it? Well, if you were wondering why this presentation is sitting in the business intelligence track here today, that's because that is our bridge from all that huge amount of data, could be structured data, could be unstructured data. The end users, some people want to see it in a dashboard, a heads-up cockpit. Some people want to see a printed report. Some people want to see it on a cell phone or a tablet. Some people want to take that absolutely beautiful dashboard that you spent months, years of your life building, and they want to export it to Microsoft Excel. So that's good. We need to include that. And along the middle, how do we bridge that gap? How do we bring the front-end people to all that back-end data? The answer is business intelligence. It's a way of getting from lots and lots of sources presented in a way that the end user wants to see. From an end user standpoint, their user requirements are not that complicated. They want everything to be as fast as possible, virtually instantaneous, require no training at all, make sure it's fully interactive, they never have to install anything, and that when they get into the application, they can start doing stuff within a couple of seconds. Actually, that's really, really difficult. I blame actually iPhones for this. If you install an application on your iPhone and you can't figure out how to use it within 8 seconds, you will delete the application. Or put it in a folder titled Applications I Hate. Everything is really fast. If on my iPhone, if I lift my finger off and it hasn't given me a response yet, I start going, wow, something's broken about my iPhone. I need to slow down apps or something like that. We've all become trained that every version of the phone that comes out gets faster and faster than the prior version. That's what people expect nowadays out of business reporting. I need it to involve no training, really, really fast, completely flexible. I need to have full control over it. It's no longer the days of, I'm giving you this report, so by God, you have to live with that report I'm giving you. So how does Oracle handle that? Because this is an Oracle presentation. If you're counting, I only mentioned Oracle one time up to this point. Their answer is this middle layer, what they call the Business Intelligence Foundation Suite. So at the bottom, analyzing big data is, as I said before, analyzing structured data plus unstructured data. So you might have structured information, things like OLTP, online transaction processing. You might be analyzing your data warehouse, your data mart. Maybe you're pulling in some GUOB information. But eventually, you're going to get to pulling in unstructured data or semi-structured data. Semi-structured data might be like log file information. There's some order to it, but it's not set up in nice records and fields. It's just a lot of text that appears in log files. Or it could be unstructured data, things like that social media information that's coming in. So the solution for how Oracle recommends we analyze that is threefold. If the data is fully structured, if it's time to put up that nice little wedding tent out there, they recommend the BI server. This is Oracle Business Intelligence Enterprise Edition, the server component. Think of this as your virtual data warehouse layer. It does not require you build a data warehouse. It's going to build that for you if you want it to. But it's going to take all the data that's out there and make it seem like it's in a data warehouse, make it seem like it's in a GUOB. Essbase is my source for semi-structured data. I might have data in 10 different places. It may look totally different. I want to bring that together and make it seem like it's in one place. That's my GUOB technology. That's Essbase. This third technology is what Oracle acquired a couple years ago. It's called Endeca, E-N-D-E-C-A. Endeca is Oracle's answer for unstructured data. Now, I'll tell you, one of my clients in the United States is a company called Land O'Lakes. They're the world-leading maker of butter, actually. And it's a $1 billion a year operation. And what they want to find out is why sometimes the cows give milk and why sometimes the cows do not give milk. Well, you'd think the cows would nicely put all that information into a relational database, but they do not. They do not answer questions very nicely when you ask the cows questions. Why are you putting out half as much milk today? Well, so what they have to do is they have to rely on comments from the people milking the cows, or the people running the machines that milk the cows. We take all of this information in, and it's a lot of text. It's a lot of survey information. And what they'll find is, oh, the cows in the western half of the United States are not doing very well because there's a drought. There's not as much water. The cows aren't drinking as much. The milk production is decreasing. On the other hand, out in the eastern United States, they have really, really nice grass. It's been beautiful weather. We've started injecting them with the right hormones. So congratulations, we now have wonderful milk production out of the east. But these are not trends they can nicely go look for. Endeca looks for it for them. Endeca looks at all that survey, all that text information people are saying about the cows, and figures out where are the actual trends and actual patterns. Now, all three of these technologies have to work together. So if we can figure out how to sort the data and arrange it into a relational database, we can use the BI server. If we can figure out how to sort it, maybe not arrange it, but at least sort it, we can put it into a GUOB, we can put it into Essbase. If we can't even figure out how to sort it, if it's just a massive amount of data, we just want to mine through it all, now we're talking the Endeca product. Now, whether you use Endeca, Essbase, or the BI server, it shouldn't matter to the person who builds the database how the user wants to see it. If I want to see it in a dashboard, or I want to see it in Excel, or I want to see it on a cell phone, that's my business. So all of those tools up top talk to all of those tools down below. All we have to agree is that if I look at it in a dashboard, or I look at it on a cell phone, it better be the same number. It shouldn't be a different number depending on what format I look at. So each one of these things is going to allow the user to see it in their own way, but make sure that it's one common number coming back in. So I'll be showing more of this afternoon in terms of how you can display this data in a mobile fashion. But in terms of all those tools up top, the answer to that is Oracle Business Intelligence Enterprise Edition, or OBIEE. OBIEE is my kind of, could be a dashboarding tool, could be a grid tool, could be a charting tool, could be SmartView inside of Microsoft Excel, Word, or PowerPoint. OBIEE is my solution to all of those. Oh, and I'll talk about this again later on this afternoon, but we do have mobile access as well. Every one of those will display on a mobile type device, because another thing that we're requiring nowadays is we don't want to wait and get a printed report. If there's a problem in my business or people are saying bad things on social media, I have to be able to pull all of that up instantly. So with that, I've taught everything that I possibly could in 40 minutes about big data, about analyzing big data. The overall presentation has about 10 more slides in it that provide some additional information on how you can go and actually set up Big data, it's a simple three-step process. Number one, understand where you currently are, what the data is you want to capture. Number two, what you're trying to prioritize, what order you want to do it. And three, make sure that you're regularly showing success. And I'll leave you with this one thought, because you will have access to the full slide deck. I'll leave you with this one thought. Where are we going with the world of big data? So they went and analyzed, in this case they analyzed European companies, and they said, what is big data going to help you solve that it hasn't traditionally? Almost half the companies said it helps them manage their risk. It stops their company from getting surprised when things happen. 43% of companies say that it helps them make products the market actually wants to see. 40% of companies say that it will help them do a better job of analyzing IT. 36% of companies say that it'll make their customers happier. It'll give them a better user experience, or it'll help management get better control. 32% says big data is going to help their sales increase. 29% say it's going to help optimize their supply chain, and 27% say it's going to get a big handle on their finances. So no matter how you use big data, if you're not doing it right now, it will be coming. So make sure you stay up on all the technology. Make sure you stay up on reading about big data. Make sure you keep understanding, reporting, and analysis. Thank you very much. I hope you have a great rest of the conference.